Welcome to the Intelligence Briefing Live What's the Buzz, where leaders and hands-on experts share how they have turned hype into outcome. Today, we'll talk about fine-tuning and operating generative AI models. And who better to talk to about it than somebody who does that actually for a living, Aryan. Hey, Abby, thank you so much for joining.
Thank you so much for inviting me. And by the way, you've pronounced that word perfectly. I'm surprised.
Awesome.
𝗟𝗏𝗏.
Yeah. Hey, why don't you tell us a little bit about yourself, who you are and what you do?
So I am a machine learning engineer who's currently working on a startup building orchestration tools for goal-based agents. I also do some consulting on the side as an ML engineer for very conventional MLOps kind of work, which I've been doing for about a few years now. Outside of that, well, right now I'm working on the book, and you'll see me pop up in a lot of venture capital meetings every now and then, but only if it's related to AI and large language models.
That's awesome. Thank you so much for sharing that with us. It's I think the most technical session and episode that we have today. So I'm really excited to have you on. Like I said, you come highly recommended from the data community and leaders in the community. So I'm so excited that that's working out today. Thank you. And so for those of you in the audience, if you're just joining the stream, drop a comment in the chat where you're joining us from today. I'm really curious how global our audience is again. And don't forget to subscribe to my newsletter, The AI Memo, at intelligence-briefing.com/newsletter, so you can stay up to date how you can successfully run AI projects in your business. Now, with that out of the way, Abby, should we play a little game to kick things off? What do you say?
Yep, let's go.
Okay, perfect. So this game is called In Your Own Words. And when I hit the buzzer, the wheels will start spinning. And when they stop, you see a sentence. And I would like you to complete that sentence with the first thing that comes to mind in your own words. And to make it a little more interesting, you'll have 60 seconds to do that in your own words and why. Are you ready to play What's the Buzz?
Yeah, I'm sorry to disappoint if I don't do it in 60 seconds.
You can go over too. So, all right, let's get started then. So if AI were a book, what would it be? 60 seconds on the clock? Go.
Harry Potter.
And why? Why Harry Potter?
Because there are so many magical creatures and so many magical spells that are coming out regularly for each of the different animals. We have a different spell, and like the Harry Potter people are popular and they're somehow considered better than Muggles or
Yes.
I don't know what's the ideal word, but there's normal people and then there are magicians. And I think in the same way, there are normal people and then there are AI people right now.
I like that analogy. That's awesome. Right. And it seems like there's always a sequel, right? There's always a next one coming. So as we're going through the hype cycles and the motions, there's always the next one coming too. So I love that idea of Harry Potter. Awesome. Maybe going back to something more tangible in the topic of our episode. Obviously generative AI has been a hot topic for a number of months now, this year definitely, but already since last year with Midjourney and DALL-E and all these remarkable inventions and progress that we've made as an industry. And now you can get language models, large language models like GPT off the shelf from the likes of OpenAI or Anthropic and others, and you can integrate them into your applications. Right? And everybody's kind of trying to figure that out, and their leaders are asking them, well, go figure out what we can do with this ChatGPT generative AI type thing. But I'm wondering, what do you actually do when you need more specific results than what these large generic models can give you that have been trained on vast bodies of text that's been scraped off the internet? How can you tailor them to your specific industry or domain?
So maybe I think something we should ask even before And it completely depends on who the audience that we're talking to here. The first question would be, do you really need these large language models? Because the first part is they come in pretty expensive. Plus, you have reduced interpretability, just because, of course the models were black box, but there are so many more questions because of the generative nature of these models, which lends to like the lower interpretability in the first place. So that's the first question I would ask, which is, why do you think you need a generative model in the first place? It's not ideal for every use case. It's not ideal for every single industry, depending on, do you have the infrastructure to already think about what are the downsides of it. So, for example, there are some industries that do require more compliance. If you don't have the end answers to how do you plan to deal with the cons of generativity, and the biggest problem in generativity right now is how do we really evaluate our models. If you don't have an answer to that, then I mean, don't even talk. Let's not even talk about fine tuning. Let's not even talk about language models. Maybe, I mean, I know it's my bread and butter. I'm writing a book on the topic, but I would really highly suggest not to use a generative model just for the heck of it.
I think that's a great suggestion, right? First of all, figure out if that is something you need to begin with, or are you just giving into the hype and just jumping into the bandwagon because you feel everybody's doing it or your competitors are doing it and you should be doing it too. So I really like that suggestion to stop for a minute and think, do we really need that?
So the way I would go about it is I would ask two questions. The first question is, why do you need it? Second question is, have you done a cost assessment of these models? And not just basically what is the cost of inferencing these models, but what are the other costs associated with these models? And that comes, so we have a paper on that. It's on my website. I'm not supposed to advertise it because of the double blind policy, but you can go check out on the website. But I will tell you a little bit, which is, um, so with most of these large language models, there are a few things to think about. The first thing is whether you do fine tuning versus prompting. Let's say you choose to do prompting, then who in the team is actually doing prompting in the first place? Um, because we indirectly create so much dependency on that person. Will it be a data scientist who's doing the prompting versus annotators back in the day? Is that the best use of a data scientist time to be able to do prompting? Now, every single time you have changes in the API itself from, or anytime you're updating the model as well, a lot of work that you've done or a lot of infrastructure that you've built around the prompt itself, which is chain of thought prompting, which is one of the techniques of prompting, might or might not be useful and needs to be rewritten. Is that worth the work as well? And all of those things are come with cost, because again, you're paying people, everybody is on a payroll for those many months until you're figuring it out. uh, so that's an important question to think of. Which, and the second question to think of would be, as you, there's a cost to evaluation for these models right now, because everything needs to have almost human in the loop depending on the use case as well. So for example, if you're doing copywriting, then I don't think we have that much need for having humans in the loop, other than, we have some baselines that are taken care of. The first baseline would be the toxicity reduction. The second baseline would be the answers aren't, we do some sort of sentiment analysis on it, and the answers aren't like really very strongly political ideology based, but also they can be, depending on who you're serving as well. So for example, like if the people that you're interacting with or if the people that are using your platform is mainly journalists, then it's fine. But then the model requires constant fine-tuning, constant monitoring as well throughout. So all of these things would pile up into cost eventually down the lane. Even if you're planning to do fine-tuning as well, if fine-tuning has a different cost as compared to the cost of inferencing or the prompting of the model itself, which is almost 4 times the cost. And unless you have a way to be able to evaluate a model, you don't really know if fine-tuning is working or not. So yes, you're spending that much money, and if you don't really know what's the output out of it, and this is a question that we kept asking in the ML industry, which is, let's tie the models back to the business KPIs. So I think the same question of tying the models back to the business KPIs reiterates, and justifying that cost before we eventually go into fine-tuning, before we actually discuss, there's some benefit out of doing domain-specific fine-tuning.
I think that's a great point that you're making, right? It's especially the cost, right? Everybody is so excited about the possibilities, and we want to try this out. We need to try it out, and might overlook also operational cost in the long run, whether it's or specifically around fine tuning, right? So I think it's important that you highlight that, and I really like how you've described that we need to think more about that as we're venturing into generative AI. So there's more to it than just calling the model.
Yep, and knowing whether we are doing an experiment versus, because there's some sort of like expectation attached to an experiment versus we think these models are going to change the world.
Yes.
Or we think we should build a large language model just because everyone else is, and somehow model creators would have some sort of moat that others wouldn't.
Yes.
Which is one of the common themes that I've heard from a lot of people, which is, if we're using the OpenAI models versus creating our own models, somehow we're not as sophisticated unless we're building a model ourselves.
So what I'm hearing then is maybe not everybody needs to build their own model or needs to do the fine-tuning. But maybe then that would beg the next question. When should you even think about fine-tuning an LLM, and what are the prerequisites that you see?
So I think there's 2 levels of understanding in this. The first thing is, what is your infrastructure like, or who is the end user? So basically, there are use cases where you can use a large language model out of the box, a proprietary large language model out of the box. So for example, you can use GPT-3 to be on your chatbot website, if it's just a chatbot which needs some sort of interaction. Versus now, if we need to give it if we are really just trying to give it data that can make it domain specific, for those ones we have chaining tools that would allow us to be able to feed data from our databases for some specific scenarios, and also to be able to save up some cached results in S3 or wherever you intend on saving, or in a vector database, to be able to pull up those questions. So for example, like FAQ question answering, you basically, like if you're an e-commerce company, you're not interested in giving answers on who's the president of the country right now. It's just not relevant. So it's important to have that one distinction, which is, do you think you need an out-of-the-box model, or do you want to give it more data internally? Now, if you want to give it more data, then what's your use case? If the use case is just question answering, then probably you don't need tons of fine-tuning if you know what are the kind of questions that you get almost all the time. Versus, let's say, or even like recommendation systems. A lot of people are now exploring using large language models for recommendation systems. Even for those, you don't need extensive fine-tuning to that extent. Versus, let's say, if we are trying to build almost like the language model version of, you could say, I'm blanking out the name. I think it's Jasper, where the goal is very specific, which is copywriting. Now, let's take copywriting, but we are writing essays for college students. Let's say there's a service that allows you to be able to write college essays. Then that's a very particular use case that can be trained on a lot of data, and that can require that extensive fine-tuning based on how accurate you want the results to be.
Awesome. So definitely weigh your options and understand what it is that you're trying to solve for, whether it's more of a generic answer or if it's more specific to your domain or to your use case. I'm taking a quick look at the chat, and I see we indeed do have a very global audience. So from Connecticut in the US to Israel to London, LA, Tamil Nadu, other folks from India. Thank you for staying up late and for joining us. Also, if you do have questions, please feel free to pop them in the chat, and we'll pick out a few for 𝗟𝗿 to answer. Maybe we'll move on to the next question. And if you mention fine-tuning, certainly for certain use cases, it makes sense. But we also know it's very resource intensive. It's very cache heavy. If you want to do that to some extent as well. I remember, for probabilistic models, you would collect data, you would improve them all during the next training, and then you push it out again. How do you do that for foundation models and for fine-tuned models? How does it change, or what of it maybe even stays the same?
So I would say, there's one key difference with generative models versus discriminative models. With the discriminative models, most of the time, if you were not doing some sort of fine-tuning, you weren't really getting any specific results, right? A lot of effort was really spent on hyper-tuning the parameters, to the extent there was almost a level of craziness with hyper-tuning the parameters. But it depends. Like, most of the value add wasn't really done from fine-tuning the parameters. Sure, you could get a layer bump in accuracy if that's generally what you cared about, but that wasn't what made the big difference. The big difference what were the features that we were looking at. How do we do feature engineering, right? If we've done everything right, which is you've done data collection, you've identified the key features, you understand the correlation as well as causation between different variables itself in the model, then that is where the biggest value add was. Once you were past that initial limit, then it was more like, okay, let's think about fine-tuning our models and improve the accuracy of the model. So I think fine-tuning was almost always just about optimizing for that 0.1% gain. And that wasn't the most important. I mean, sure, from a research perspective and from all of us who grew up on Kaggle in a way, we enjoyed that as a practice. But when it came to the real machine learning projects, at least in the industry, that's not where a lot of effort was really invested.
Right, I see. Yeah. Maybe on that note, I'm taking a look at the chat, and I see one of the questions here is, what are the models that can be used in insurance? And maybe there are other domain-specific models, or maybe there's an answer that you have that addresses different use cases, different domains, different industries. Is there anything available that you know that's public, that's known, or how can you maybe customize it based on your industry?
So I think there are two kinds of generative models right now. One are the OpenAI models that are more like, you can call them general models in a way, because despite the fact they're trained on a very specific kind of unstructured data, and there's a lot of data that they haven't seen, but they're constantly improving to include more domains. And the second are basically large language models that have been trained on very different data sets. So for example, Bloomberg GPT comes to mind. That has been trained specifically on financial data. I'm pretty sure there's, so I've not really seen something which is specifically used in insurance itself. But I think I'll probably mention this, which is in terms of the performance itself, and depending on who the creator of the model is, how much data did they have access to. A financial model, which is a model that is trained on financial data, is slightly better in performance as compared to like a generalized model.
I see. Good. One of the other questions that Seth was asking here is, are there any resources available that lay out the evaluation of the different models that you've described? I'm assuming Seth is referring to the more probabilistic versus the generative type models, which ones to choose for what purpose. But maybe Seth, if I'm not summarizing your question correctly, feel free to add again. So different ways to evaluate which type you should go with.
Right. So as of now, for to be able to evaluate the discriminative models, we had tons of parameters available to us. And the very obvious, you are looking at the F1 scores, you're doing some sort of cross-validation, you're looking at the R value, you're looking at the precision, you're looking at the recall. It was very easy with the discriminative model. With the generative models, the evaluation is something which is specific to the use case as well. So as of now, if you've been seeing the evaluation frameworks out there, there are two kinds of evaluation frameworks that are sort of available to almost everybody on the internet. The first are the evaluation frameworks like Stanford HEM, which in a way sort of breaks down, these are the parameters that you should be looking at, but it's very generalized as well. And they've sort of compared what is the performance of one versus the other. The second thing is there are also some sort of leaderboards that are a little bit more domain specific. So for example, for question answering, and there's this company called 𝗟𝗵𝗴𝗲 Labs that has created their own leaderboards as well. So for example, which model does perform better on question answering? But again, like a word of caution I'll give over there is it looks for if your model does well on so all the evaluation frameworks that are provided there are best used to be able to establish some sort of baseline only. If the model is good enough to be able to perform well on question answering, but it doesn't really mean that it will answer well on your specific domain as well. So there needs to be more work in terms of domain-specific evaluation that needs to be done on top of the question answering as well. So as of now, evaluation is more like an open question that way, which is like a lot of people are looking at how to evaluate your models. And while there are three things that you're technically looking at, which is one is what is the accuracy of the model, the second is what is the inference speed of the model, and third is what is the latency of the model as well. While these are things that you can sort of measure, which is I would quote unquote put them inside what I would say performance. These are the performance metrics. But outside of performance metrics, there are so many things that need to be taken care of, because the next question comes, how do we define the accuracy? What is a good enough inference speed? So on each of these, which is on accuracy, on inference speed, on latency, establishing some sort of baseline, is it acceptable enough for us? So for example, like if we're working with a chatbot and we have a latency of our model does give us an answer in, let's say, 30 seconds or 1 minute. That's a very long waiting time when you're interacting directly with the customer. But versus we're using a large language model to be able to do a knowledge retrieval on a bunch of internal documents where we can wait. I mean, the fact that we're able to do natural language prompting on a lot of Excel sheets that we do have, or on a lot of PDFs that we do have internally within the organization, the team internally wouldn't mind waiting that much.
Right.
So it depends on who the end user would be and what would be an acceptable level for each of those things. So while having a higher latency is almost always preferred, but it doesn't mean that uh, it's always the most ideal solution. Different use cases or different users as well can have very different baselines on each of these things.
Awesome. Thank you for sharing that. I think that then again puts it in a very good context, especially if you're familiar with the metrics that you mentioned, like the F1 precision recall and everything that we've done before. Generative AI was the big thing, and then now what I heard you say is make it use case specific. If it's more end user focused or more customer facing, then there might be different expectations regarding latency than if it's an internal scenario where maybe this runs in the background, or they're not
and
as
maybe I'll say
required.
this as well.
Yeah.
Maybe I'll say this as well, which is, as of now, there are two kinds of benchmarks that are available to you. The ones are the closed benchmarks, and as we go further, maybe there will be more closed benchmarks as well, where you're able to feed your model into the evaluation framework and to be able to evaluate it. And they're open source frameworks as well. So for example, what I really mean is on the proprietary, or the closed ones, are something called OpenAI wells, where you're giving out your model, you're training it, checking how your model does perform. The second example on that is I think 𝗟𝗏 is working on an offering as well, because they've put out this open source project called 𝗵𝗲, and I think they are planning on putting a managed evaluation framework for your models on their platform, because I think that's how they do their releases in the first place. And the second are more publicly available benchmarks, which would be things like Helm, or things like Eval's harness, which is by 𝗟𝗏, which are completely open source, and depends on how you're actually able to use them. So what I would say is there are these two kinds of things, which is there's NeMo guardrails, OpenAI wells, there's anything by 𝗟𝗏. The second is from communities and from researchers, where you don't have any managed architecture to be able to see everything. It's almost like they've given an evaluation framework. It may or may not be maintained. It may or may not be adapted to your particular use case. The performance might not be that well, but it gives you a way to be able to think. And in that category, I would say is Stanford HIM or Eval's harness do sort of fall into that category. But also there's more people looking at different methods as well. So for example, one of the things that a lot of people now are looking at is also some sort of basically some sort of scoring based methods as well, to be able to see if the models are performing well as well or not. So, but again, there's not a lot of framework, there's not a lot of providers, no open source work in that particular thing. So it's more like, well, yes, you have some things which are available, but it's almost like it may or may not work.
So it
But it
sounds
will
like,
give you a way to think about the problem.
I see. So it sounds like on one hand it's use case specific, but also depending on the frameworks that are available or which ones you choose, it might be a bit early still to get to something that's standardized.
For elo-based benchmarks, it's
Yes.
very early because I've not really seen any framework for elo-based benchmarks.
Okay.
So what I've really seen is more like benchmarks that are around toxicity detection, that are around sentiment analysis, that are around, one of those generalized use case. But I think the elo-based benchmarks are the only ones that are very domain specific. But the discipline around that is not really developed yet. I think it would take about 6 months to about 1 year for there to be like an established framework for around elo-based methods.
I see. So we're getting close to the end of the show. Thank you so much for sharing all those insights where you see we are with large language models, how you can adapt them, fine-tune them, what changes when you want to operate them. I was wondering if you can maybe summarize the 3 key takeaways for our audience today before we wrap up.
So I would say first is think about whether you really need to use a large language model. The second thing to think about is whether you want to do fine-tuning versus prompting, which is a better use case for you. So for example, like whenever you can have a sort of chain of thought way of thinking about a problem, it's much better to be able to think about prompting as compared to when you're looking at your data and you realize, the function that you're trying to optimize for doesn't really have those very obvious connection. It's a very complex function if you're trying to write the function that you want to optimize for in terms of the inputs and outputs. If it's a simple function, do prompting. If it's a little bit more complex, where there's more nuances within the variables itself, then I think fine-tuning is going to be slightly better in terms of performance. Once you've done that, the next thing, or maybe it should have been one of those things that you should have thought about earlier, which is more so think about how will you evaluate your models and what are the who's the end user for the model as well, and what are the risks that come with any sort of evaluation. So for example, any time that you're evaluating using OpenAI evals, you're exposing your data entirely to OpenAI. And they can use that to be able to train further models. So you're in a way sort of leaking out your models. And this was brought to attention by 𝗪𝗲 𝗟𝗏 from Stanford, who said this is sort of not ideal.
So there's also the IP component and data privacy component to it, right?
Exactly.
Yeah.
Exactly.
Awesome. Well, 𝗟𝗏, thank you so much for summarizing it. Thanks for joining us today and for sharing your expertise with us in such great depth. I know it's an exciting topic, and I wanted to make sure that our joint audience has an opportunity to hear from you and to learn from you, and especially to go deeper than everybody should be doing generative AI and get on the bandwagon. So I hope we're able to accomplish that. So for those of you in the audience, again, thank you, 𝗟𝗏, for joining.
Thank you so much.
Awesome. Well then, we'll see you next time for another round of the Intelligence Briefing Live. What's the buzz? Bye-bye.
It went by too quickly.